Hi everybody. So in this video, we're going to look at angled projectile motion. So we'll use a lot of the ideas we did in our previous video on horizontal projectile motion. Okay, so in example 1, we're told that a golf ball is struck from a point on horizontal ground with velocity 29I plus yj in meters per second. And this is at an angle of alpha to the horizontal. And we're told that the ball takes 5 seconds to land on the ground at point G. And then for part A, we've been asked to work out y, which is this y here, the range, and the maximum height reached by a golf ball. Okay, so with questions like this, the first thing we need to do is to sketch the trajectory of the golf ball. So we have our axes. The golf ball starts at the origin, and it travels upwards, and then returns back to the ground after reaching a maximum height. Okay? We're told here that the initial velocity is 29I plus yj. So we can show that through this line, which starts at the origin. So we're saying this is 29I and yj. And I'm going to write it in column vector form. And this is in meters per second. And we're told that the angle between the velocity and the horizontal is alpha. So I'll show this here. And then we're also told that the ball takes 5 seconds to land at point G. So we'll label this at point G, and we'll say that t equals 5. Okay, so to work out y, we need to think about resolving this vertically upwards, because y is the upwards vector. So resolving upwards, we can use our CVAT equations. So the displacement is 0, because it starts here, travels up and goes down. So it's 0 displacement from where it was initially. The initial velocity we know is y. The final velocity isn't relevant, and we don't know. The acceleration, well, on our diagram, the acceleration is going downwards. So this is negative 9.8. And the time, we're told, is 5 seconds. Okay, so we can use the formula S equals ut plus a half at squared. We'll substitute in our values, 0 displacement, an initial velocity of y on a time of 5, so we'll call this 5y. A half of a is negative 4.9, and this is t squared, so times 25. So we can solve this equation. We'll move this to the left-hand side. So we get 122.5 equals 5y. We'll divide both sides by 5, so y is 24.5 meters per second. Okay? Then for part B, to work out the range, well, I'll show this on the diagram. This is the range here. So because we want to work out the distance from here to here, we're going to resolve horizontally. So again, we'll use our CVAT. So displacement we're trying to find, we'll call this x. The initial velocity is now given as 29. So u equals 29. Again, we don't need v. The acceleration, so although we've got an acceleration due to gravity, this is only acting vertically downwards. We've got no acceleration horizontally. So in this case, a is 0. And we know the time is equal to 5. We can use the same formula. So ut plus a half at squared. We know s is given as x. The initial velocity is 29, and the time is 5. This bit we don't need to worry about because the acceleration is 0, so all of that will become 0. So we can work out x as 25 times 9, and this will be 145 meters. Okay? And then for part C, to find the maximum height reached by the golf ball, well, I'll show this on our diagram. This will be this height here. And you can see at this point, the maximum velocity is 0. So using our CVAT equations and resolving vertically upwards, our displacement is h, our initial velocity is 29, v is now 0, the acceleration is negative 9.8 because we're going upwards, and the time is now not needed. So now we can use the formula v squared equals u squared plus 2as. We'll substitute in our values, so 0 will equal 29 squared plus 2 lots of negative 9.8 multiplied by the displacement h. We'll move all of this to the left-hand side, so we get 19.6 h is equal to 29 squared, so h will equal 42.9 meters. Okay, let's move on to example 2. Okay, so in example 2, we're told that a ball is projected with a speed of 13 meters per second at an angle of 25 degrees above the horizontal. Assuming that the ground is horizontal and the ball is struck from a point 1.5 meters above the ground, we've been asked to work out the maximum height above the ground that the ball reaches, and then to find the horizontal distance travelled by the ball before it hits the ground. So again, we're going to sketch a graph of this motion. So we're told here that the ball is struck from a point 1.5 meters above the ground. So I've shown this here. This will be 1.5. Draw the ball now. And then the motion, the trajectory, will be to go up and then to come down. We're told that it's projected with an initial speed of 30 meters per second. So we can show this here. We've got 30 meters per second at an angle of 25 degrees to the horizontal. So we'll have this on our diagram. And then because we're asked to work out the maximum height above the ground that the ball reaches, we know this length is 1.5. So all we need to work out is this length. And I'll call this length x. Okay, so to resolve the maximum height, we'll resolve vertically upwards. The displacement we're going to call x. And then to work out the initial velocity, we'll call this uy. We need to work out the vertical component of this velocity. Well, if we're going upwards, because this does not contain the angle, this will be 30 sine of 25, which works out to be approximately 12.7 meters per second. We know the final velocity will be 0, and the acceleration will be negative 9.8. And we don't know the time. So now we can use v squared equals u squared plus 2as. And this will then allow us to work out the displacement, which we're calling x. So substituting in our values, we've got 0 will equal 12.7 squared minus 2 lots of a, so negative 19.6 times x. We can solve this equation. We'll move this to the left-hand side. So 19.6x will equal 12.7 squared. So x will equal 8.2 meters. And if this is 8.2, and we know this is 1.5, then the maximum height will be 9.7 meters. Okay. And for part B, the horizontal distance travelled by the ball before it hits the ground, well, this will be our range. So if we look at resolving horizontally to find our range, so we know the displacement, I'm going to call d now for distance. I've already used x. The initial velocity, well, the initial velocity I can find by working out this component of the 30 meters per second. And because this does contain the angle, it'll be 30 cos 25. which works out as 29.7 meters per second. The final velocity we don't know. The acceleration we know is 0, and we don't know the time. Okay, so at this point, we can't really go any further until we work out this time. But we know the time it takes to travel here is the same as the time it takes to travel this way. So we can work out the time by resolving vertically upwards again. So resolving vertically upwards to find t, we know the displacement from here to here will be negative 1.5. We've already worked out the initial velocity as 12.7, and we know the acceleration is negative 9.8. So using s is equal to ut plus a half at squared, negative 1.5 will equal 12.7 t minus 4.9 t squared. If I just move this over to here to give myself more space, we can solve this quadratic. So 4.9 t squared minus 12.7 t minus 1.5 will equal 0. We can solve this and we get t is 2.71 and t is negative 0.11. But we know this solution isn't valid because time can't be negative. So our time then is 2.17. So we'll substitute this back into here, and then we can work out our range using the same formula. So d will equal 29.7 times 2.71. We know this acceleration is 0, so all of that will go. So d will equal 80.6 meters. Okay, let's try one more question. Okay, so in example 3, we're given that a particle is projected from point P on level ground with an initial velocity of u at an angle of theta above the ground, where tan theta is 3/4. The particle hits a wall at a point 4 meters above the ground, and the wall is at a distance of 32 meters from P. We've been asked to work out the initial speed of a particle. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So I've drawn our diagram. We've got the trajectory of a ball. The initial velocity is u, gravity acting downwards, a range of 32, and it hits a wall at a point that is 4 meters high off the ground. Okay, so the first thing we need to think about here is to work out u. And because we haven't been given theta, we can use tan theta is 3/4. So if I sketch a right angled triangle here, because tan theta is 3/4, we know the opposite will be 3, the adjacent will be 4, so it's not quite to scale. So we can work out the hypotenuse as 5 using Pythagoras' theorem. We can work out the initial velocity as the hypotenuse, u, multiplied by cos theta, so 4/5. So this will be 4u/5. The vertical component, uy, will be u multiplied by sine theta, so the opposite divided by the hypotenuse, so 3/5. So we're saying this is 3u/5. Okay, so now we've got our initial velocities in terms of u, we can work out the time, because the time taken to go horizontally for a displacement of 32 will be the same as the time taken vertically to go from here to the 4. So if we resolve upwards, we know our displacement vertically upwards is 4, our initial velocity is 3/5 u, our acceleration is negative 9.8, and we can work out the time as capital T. So our displacement will be 3/5 u times t minus 4.9 t squared. Using the same idea, but resolving horizontally, we know the displacement is 32. Our initial velocity is now 4/5 u. Our acceleration is 0, and our time is again capital T. So now 32 will equal 4/5 u times t. So what we can do now is we can make t the subject of this equation, then substitute this value of t into here. So t will equal 40 over u. So if we call this equation 1 and equation 2, then we substitute 1 into 2, we'll get 4 is equal to 3/5 of u times t minus 4.9 t squared. So 40 over u all squared. So all I've done, I've substituted this into here. And this works out quite well because we can cancel these two out. So now we can work out 3/5 of 40, which is 24. And then we can work out 4.9 times 40 squared. So we get 4 is equal to 24 minus 7,840 over u squared. And then we can move this to the left-hand side and the 4 to the right-hand side. So therefore, 7,840 is equal to 20 u squared. We'll divide both sides by 20 and take the square root. So u will be 7840 over 20, which gives us 14 root 2 meters per second, or approximately 19.8 meters per second. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.